Daniel Hahn, who has a background in marine ecology. Dr. Hahn has spent has past 15 years conducting natural resource damage assessments for oil and chemical spills throughout the Gulf of Mexico. He is currently the primary NOAA NRDA spill coordinator for cases in Louisiana, Mississippi, Alabama, Florida, and the U.S. Caribbean, and the offshore waters of the Gulf of Mexico. He works with multidisciplinary teams of biologists, chemists, economists, and lawyers, and in coordination with federal, state, and local agencies to assess injuries resulting from oil spills and chemical releases.
Well, as is typically the case, the NRDA people are still here. Everyone else has gone home. No, thanks for everybody for sticking around. We've got a pretty varied audience, and I don't know who all is online. So the talk I'm going to give here kind of covers a breadth of basics of injury assessment and the natural resource damage assessment process, and really tries to tie in a lot of the science that's been presented here. It's going to touch less probably on the science than if it was just the scientists sitting down in a small group. So here's what we've got. We've got a spill, and our responders come in and they put out the fire. Some of these analogies really help us. So everybody's happy, right? This was your house. The firefighters came in. The fire is out. You're like, awesome. Actually, you think to yourself, well, wait a minute. I have a burned out wet house. And so what you need is someone to come in, assess the injuries, see what needs to be done to rebuild the house and rebuild that house. And the damage assessment process, that's the intent of the process. Assess the injuries to the natural resources and restore for those injuries on behalf of the public. So it's a structured legal process, and it's founded in science. Founded may be a strong word, but it's really a legal process. Strong science helps you have a better legal case. The better legal case you have, the better you can do in litigation, or even more importantly, you can settle the case without having to go to litigation, because the end result is restoration. And we're always restoration focused when we're conducting injury assessments and doing a natural resource damage assessment. So that goal is always restoration focused. There's a big overlap with response, however. So the entire process looks something like this. You have a spill. There's a pre-assessment phase. The responders are out there. We're collecting ephemeral data, collecting oil from the site, collecting source oil. As the response transitions, we move into an assessment phase where we may set up further field studies, conduct laboratory studies, analyze the data we've got, start identifying restoration projects, scale projects, and then ultimately we either go to litigation or we settle the case and then we implement restoration. It's a long process, and behind all of this process, you can see these shadows back over there. That's the public. So this is why we're doing this on behalf of the public. We're acting as the trustees for the public's resources. So throughout the process, we try to get input from the public. What resources are of importance to them? What restoration projects would they like to see implemented? Are we acting in a good manner on their behalf? Natural resources seems like a pretty basic thing, and it really is. It's the land, the fish, the wildlife, the biota, air, water. We all think of, usually anyway, we think of these kinds of things like the charismatic megafauna like dolphins and the charismatic minor fauna like amphipods. But we've got a lot of different things, and Isabel just mentioned this character here, the mesopelagic realm. We have a wide variety of life out there, and understanding its connectivity and the injuries to the system as a whole is always a goal, but it's also a huge challenge. That connectivity really is one of the drivers, the services that these individual natural resources provide. So it's not just an animal itself or a plant, but the services and the connectivity, the ecological connectivity of the system, such as primary production, decomposition, food web interactions like predator-prey, supporting other organisms. And then, of course, because we're people, we always like to see, well, how does that influence us? How does it impact us? So the services that it provides, recreational fishing, recreating and just observing nature, passive uses such as that. All of these things can be injured by an oil spill, impacted by an oil spill. So the injuries themselves are defined in the regs as an observable or measurable adverse change in a natural resource or impairment of a natural resource service. Pretty simple, except that if we don't understand what was there before a spill, the baseline condition, how can we assess the but for the spill, what were the initial conditions? Isabel just touched on this a minute ago. When we had the Deepwater Horizon spill, we had this enormous spill in deep, deep water. And we looked back and said, we don't have a lot of information. We have a lot more information now, but it's still building just to give us that baseline. So for those future spills in deep waters, we've heard about dispersants being applied at wellheads, and Isabel's just shown that what we see is, these effects that linger not for weeks or months, but for years and maybe longer throughout those deep communities with that sort of deep water spill. That's something we didn't really have any grasp of at all 10 years ago. We're getting a better handle on it now, and that science and that research is really a driver and helps people like me act on, again, on behalf of the public to protect and restore the resources. In the Oil Pollution Act itself, the collection of environmental baseline data in ecologically sensitive areas, these are like the ESI things that Timon talked about and Pete and Eric both mentioned. So, having that background information is also in the Oil Pollution Act, and where there's gaps that exist. I don't know that when they wrote that, they were thinking of mesopelagic, bathypelagic realm, but certainly as we push further offshore, that baseline is really critical. And I think OPA specifically states we should be collecting that baseline information. Again, restoration focused, okay? The goal is to make the public whole. It's not a punitive process. There's no punishment involved in what the trustees are doing. We're trying to assess the injury. We're trying to restore for the injury. It's supposed to balance. Not too much, not too little. The better the science we have supporting both the injury side as well as the benefits of the restoration we conduct, the better we can make sure that these things actually balance out. So again, the science both on the front end in establishing baselines, understanding toxicity, understanding impacts, the data we collect during a spill, all go into that injury. And then the science on the backside, what does a restoration project do? Scott mentioned replanting. Some people thought that might be restoration. Others thought it was a response action. Regardless, it's an action taken, and you need to understand what are those benefits. How does it accelerate recovery? Because the recovery will dictate the ongoing injury. Faster recovery, less total injury. So there's a lot of things that are affecting the total injury assessment and the restoration needed. Locations, type and amount of the oil. We have floating oils, sinking oils, deep water spills. The response effectiveness is certainly one of those. And ideally, by talking and having our pre-planning, our area contingency plans, geographic response plans, all of our processes in place, the response minimizes the injury. The less injury we can have out there from the spill, the better, right? I mean, everyone's goal is to conserve and protect the resources. So those pre-planning things are really critical. Human uses are one of the things that are easier to quantify in terms of you can put a dollar value on them that is less questioned. So when someone can't go to the beach, it's very easy to quantify that. You don't have to link it back to its impact on the rest of a system or its connectivity, or explain why amphipods are important, or polychaetes are important, or nematodes are important, or bacteria are important, or any of these. So human uses are something we often investigate. And again, it's something that the public certainly identifies with. And then, of course, weather and luck can have huge impacts on your injuries. So revisiting the whole timeline, as the incident occurs, this is not drawn to scale, by the way. The incident occurs, the responders are out there, ideally immediately. There's active cleanup. And at some point early on, injury assessment people will start showing up. They're in the incident command. We're working in collaboration. Eventually, the response enters a maintenance phase. Injury assessment continues, and injury quantification, and then restoration implementation occurs. Those processes, restoration implementation for Deepwater Horizon is a multi-decade process. For other spills, it's going to be, maybe a few years to a decade of implementation, and then monitoring to assure that your restoration is successful. So it's a much longer process, and we have a lot of involvement throughout that process as injury assessment specialists. And therefore, the data that's collected early on is really important. We carry that through potentially to litigation. We don't wrap up our early phase and we're done. We have to carry that information through. A lot of the things that are collected early on by the damage assessment team overlap with what the responders collect as well. Source oil samples, animal carcasses, documenting and fingerprinting oil from shorelines on the water. And then we also like to study recreational use early on, because that's another piece of ephemeral information that you might not be able to get later on. How are people changing their use of an area when it's impacted by a spill? Response technologies have been mentioned by a couple of speakers, and certainly the data and the science associated with remote sensing is improving rapidly. We heard that things like SAR sometimes maybe show what looks like a large footprint of oil, and people interpret that as a big, thick footprint of oil. Some other techniques, multispectral, and some of the other techniques can actually distinguish oil thickness with satellites. So we can use them to say, here's where the thicker oils are, here's where the thinner oils are. It's on a relative scale, but it gives you an idea of where one might see more impacts, as well as where one might focus response assets. And then a little closer to the ground, but still up in the air, unmanned aerial surveillance is really a great asset. When we're out in a boat, we can't access a lot of the back marsh areas and other areas that are impacted by spills. These UAS platforms allow us to examine those areas, monitor those areas, document oil in those areas, and assess injuries. You can also use, rather than just visual, multispectral, thermal, and other bands of information in order to better characterize impacts to vegetation or the presence of oil. So response data and NRDA data are really interchangeable. So many of these things are shared pieces of information. Coast Guard mentioned earlier, they collect their sample so they can track it back to who it was. That happens where an RP will say, oh, it's not our oil. And you say, well, it sure looks like it. And that's tough to fight. We will also take that source oil, do the same thing, and then we might take it a step further and do toxicity testing with that oil later. So coordinating and collecting source oil can be done one time if everyone's talking to each other, or we can do it multiple times because the trustees are always going to want to have source oil in hand. SCAT information, where you're looking at shorelines, where oil is, how heavy it is, the better that information is collected, the better we can use it after the fact. SCAT has its own function, which is for cleanup, but making notes as to what you're seeing beyond just, yes, clean up, don't clean up, can really help in assessing injuries later on. And especially on larger spills where the trustees might not be able to cover all shorelines, sometimes that information is the best information we're going to have in the end. Remote sensing, we talked a little bit about. Wildlife response data, all of these things, closures and advisories, and then the photographs, all of these things feed back in later to support an injury assessment case. And again, that leads to quantifying the injuries and then scaling restoration on behalf of the public. So after the response is over, the trustees compile and evaluate all of their ephemeral data. They monitor the system for recovery. They draw on relevant literature. So there's a lot of studies and investigations from academia, especially, that go into that. Toxicity information. Abigail mentioned the coral toxicity testing, but there's also some work that her lab's done on mesopelagic crustaceans as well. That's something that's really a gap in the information we have. We have toxicity testing for lots of lab rat type species and a few species from out in the field, but we don't have anything from those deep waters. And I won't say what any of those results might be because I don't know, but I know that testing's going on, and my recollection is it falls within the range or is actually sensitive, a lot of the species that's been tested. We conduct lab studies and we conduct modeling. We use all that to quantify the injury, and then we start identifying restoration projects once we have an idea of what was injured and how much was injured. We scale that to restoration and then ultimately implement that restoration. These principles also apply to chemical spills. My title had chemical in it, so I had to put some chemical in here as well. This is a local spill in Tampa Bay. Some of you probably remember it, but there was a stack breach over here from a fertilizer processing area, spilled, actually over here. It spilled down in, flooded up during a tropical storm, and we were able to get out there, collect water data for pH, and create these contours of low pH along here. We pulled crab traps and found dead organisms in there, so we could say definitively this low pH was killing these organisms. Then we could go back to our baseline information, where people that work here at FWC, Fisheries Independent Monitoring, have a historical baseline of information of abundance of organisms in this bay. So we could overlap that information to develop our injury quantification. So it's a real nice way where we had the baseline information, we had strong evidence of the impacts, we can put those together and come up with an injury quantification. And then ultimately we scaled that and we came up with some restoration projects. This is one that was just implemented in its early phases. So why are we coordinating? Well, in the response kind of time frame, we coordinate for lots of different reasons. You know, we started off with a health and safety moment. That's always important. You know, a lot of coordination during a response is really critical to avoid conflicts. It also maximizes efficiency, like collecting the source oil sample once. That reduces costs. We can improve our data quality, our data management, because we have collaborative, continuous stream of information coming in that's shared. And then, of course, it provides natural resource protection. So when people are talking, you hear what resources are critical, you talk to local experts, and you can minimize unintentional impacts. So cooperation and collaboration before a spill is really critical. Coast Guard mentioned drills. You know, they don't want the first time that someone pulls out their plan to be when they have a big spill. They want to make sure they're drilling on these things. And for natural resource people like myself, it's also important to be up to speed with things, to drill. It's also important to collaborate with your local community. You know, occasionally I'll wander over to USF and talk with the researchers over there and see what they're working on at the moment. These collaborations allow you to interact face to face, get to know each other, and then during a spill, you're not, you've already addressed a lot of the issues. You're not trying to come up with solutions then. So developing working relationships, identifying controversial issues was also mentioned. We don't want to hear about new research ideas during the early phases of spill. Of course, early collaboration really helps head some of those things off and make sure that the science is there when a spill happens so that we can use that information. Here's just a brief example. This is a Chevron drill last year where UAS was used. They went into the field, put out wildlife units, put out visqueen strips to represent oil, and then evaluated techniques for using unmanned surveillance aircraft for identifying oil and identifying impacted wildlife. It was a really nice collaboration with the resource trustees and the response. So in summary, there's a lot of overlap between responders and natural resource damage assessments. Everybody's striving to minimize the injury out there, to secure a source, clean up the source, but really we're not doing that just because there's oil. We're doing it because it has impacts on the environment. Once the response is over, the NRDA isn't over. We're there for a lot longer period of time. So it's really important that the data that's collected is robust and usable in the long term. The NRDA can also provide valuable input back to response. That UAS example I gave a minute ago, we were flying that for NRDA activities. Response was primarily working from boats, and we were able to relay information back into them and say, hey, your boat-based surveys, I think you're missing some of these areas. They were able to go back out and reallocate resources. So there is some feedback among the data collection streams as well. Since we're quantifying injuries, NRDA can also guide some of the research that's done outside of any of the response communities, so by academics and whatnot. Applied research is really a focus in a lot of the RFPs that come out. And talking with NRDA folks can really help guide some of that research at times. And finally, the goal here is restoration on behalf of the public. And the better the science we have to support the injury assessment, the better and more robust the restoration we're going to have. That really benefits everybody, and really, it benefits the public, and that's our ultimate goal. So thank you. I've got my contact information up here, and I think we're going to a panel.
We're done here for this afternoon. Please make your way up. Thank you.